very good day to all. So my name is Siti Natasha binti Suhaimi. So we are from Group 5 and today we will present to you about the single state compressor experiment. So my group members are Pavitra, Raven and Anissa. Okay, so I'll present to you about the summary of the experiment. This experiment is carried out to observe how heat is converted to work by using a single stage compressor. When the power and motor switch on, the temperature of the outlet air was recorded at 1 minute intervals until two consecutive readings were the same. The readings of temperature obtained from 31 until 33 minutes is 134 degrees Celsius. Then the graph of the outlet temperature T2 over time was plotted to analyze the heating curve and behavior of the single stage compressor. Based on the graph, it shows that the outlet temperature T2 increases exponentially with time.
Hello and good day everyone. I'm Raven from Group 5 and today I will explain about the introduction and also the theory for the experiment 2, which is single stage compressor. So to start off with the introduction, let's see what is the aim of this experiment. The main of this experiment is to observe how heat can be converted into work. This experiment is conducted by using a compressor which is called single stage compressor. A compressor is a device that reduces the specific volume of a compressible fluid such as a gas or a vapor. It happens in order to increase the pressure of the fluid during its passage through the compressor. One of the key aims of employing a compressor is to compress the fluid and then distributing it at a higher pressure than previous one. An open process system by definition has mass crossing its boundary as the process occurs. One example of an open machine that operates in a steady state is a compressor. Compressor is mainly used to increase the pressure of a fluid by supplying work from an external source through a rotating shaft. In this experiment, the operating concepts of a compressor, such as heat loss from a compressor, are investigated and finally shown clearly. The temperature of the exit air is taken before the sequential readings are the same to estimate the rate at which a single stage compressor heats up when the control and motor are turned on. An air compressor is a pneumatic device that converts power, it's either using an electric motor, diesel or gasoline engine, into potential energy stored in pressurized air, in examples such as compressed air. By one of several methods, an air compressor forces more and more air into a storage tank, where it increases the pressure. The test rig comprises of Toyo or Mack make single stage compressor fitted with an air tank with orifice, pressure gauge and an energy meter to measure the input. A digital temperature indicator measures the temperature at various points. The compressor is mounted on air receiving along with the motor and is provided with air relief valve and a pressure switch as well. Some of the application of single stage compressor in industry is including bore well, chemical industries, circuit breaking, spray painting, graniting and cleaning. Moreover, pneumatic tools, liquid transfer are some of the applications as well. The air compressor turns off when the pressure in the tank reaches its engineered top limit. The compressed air is then stored in the tank until it is needed. The compressed air energy can be used for a variety of purposes by harnessing the air's kinetic energy as it is released and the tank depressurizes. When the tank pressure drops below a certain level, the air compressor kicks in and repressurizes the tank. An air compressor differs from a pump in that it works with any gas or air, whereas pumps function with liquids. In this experiment, we will see how quickly a single stage compressor heats up and how rapidly it loses heat in a steady state condition. A single stage compressor compresses and pressurizes air to transform power, typically from an electric motor, diesel engine, gasoline engine into kinetic energy. It is frequently utilized for low pressures. Moving on to the next part, which is the theory. In a single phase compressor, the air is needed to be compressed one time only. A constant volume of air is trapped between two sliding vanes driven by an offset rotor in a standard single stage vane compressor. Then the volume of air is being pushed to the outlet where the area and hence the volume as well is reduced. As a consequence, the pressure getting higher and it is being pressed out of the outlet port. The outlet temperature will increase exponentially with the time because the heating process in a single stage compressor very quick. However, even though the energy added to the air by compressor also increase, but the heat released from the compressor is decreased exponentially. The single stage air compressor works using the force exerted from a piston and pressure sensitive valve that consists of rotary vane type air compressor coupled to a turn on mounted electric motor and attached to a spring balance. The major difference between a single stage compressor and a multi-stage compressor is that a multi-stage compressor completes the compression process in more than one stage, while a single stage compressor completes the compression process in just one stage. But this compressor is less efficient than a multi-stage compressor. Two-stage air compressors create superb aerodynamics and are suitable for large industries and continuous function. Thus, due to the high price of two-stage compressors, they are not best for small pressure requirement applications. These compressors are best suitable for workshops and factories than for home use. In contrast, a single-stage air compressor powers different pneumatical tools at pressure up to 100 psi. It is the right choice for gas station and different manufacturing plants. Specific volume through flow meter can be calculated by using the formula R multiplied with temperature of flow meter divided by the pressure of flow meter, where the R is equals to 0.287 kilojoule per kilogram per K. And we have to remember to convert pressures and temperatures into kilopascal, absolute and Kelvin respectively. For the volumetric flow rate, we can calculate by using the formula V in over 60 times 10 to the power of 3, while the mass flow rate M can be calculated by using the formula V over VO and the unit will be kilogram per second. Energy added to the air by compressor Hc can be calculated by multiplication of M with C and multiplied by T2 minus T1, and the unit will be watt, while for power out of motor W is calculated by multiplication of N times with F times with L and multiply with 2 pi and 9.81 over 60. Heat emitted from compressor QC also can be calculated with the equation of Wm minus Hc. That's all from me. Thank you.
Assalamualaikum and good day everyone. I'm Anissa. In this video, I will present the experimental procedure for single stage compressor experiment. So this is the apparatus for this experiment, single stage compressor. At the left side, in the cylindrical tank, it is air flow meter, and beside it, green inlet valve, and then the air chamber input, and the next is motor, and at the below part is compressor. It works by motor there, and the left side below the air chamber input is air chamber outlet and the red outlet valve. As for procedure, first, switching on the power. Second, fully open the green inlet valve by turning the valve into anti-clockwise. Third, record the initial readings for all parameters listed in table 1 at the beginning of the experiment. The parameters are air temperature into apparatus T0, air temperature into compressor T1, air temperature out of compressor T2, atmospheric pressure from barometer P0, vacuum into compressor gauge P1, air pressure out of compressor gauge P2, flow meter V inlet, motor speed N, motor spring balance F, electric power in watts. Then switch on the motor and adjust the spring balance To make sure that the indicator on the motor is between the two black lines, and set the compressor outlet pressure P2 to 1 bar gauge using the red outlet valve, which is turn the valve by clockwise to increase the pressure. Then, record the temperature of the outlet air T2 at 1 minute intervals by using a stopwatch until two consecutive readings are the same. Lastly, use the tachometer to record the motor speed. So to stop the experiment, first reduce the compressor outlet pressure P2 to 0 bar gauge using the red outlet valve by turn the valve into anti-clockwise to decrease the pressure, and switch off the motor and the power.
Hello everyone, my name is Pavitra Chandramohan and I'm going to explain about the results and discussion. For the results, Table 1 shows the list of parameters for the single-stage compressor unit, which is recorded at the beginning of experiment, while Table 2 shows the outlet temperature data over time, which data was taken at 1 minute time interval. For the calculation part, first we calculated the volumetric flow rate, which is 0.005 meter cube per second. Secondly, we calculated the specific volume through flow meter, which is 0.84602 meter cube per kilogram. Thirdly, we find the mass flow rate, which is 0.00591 kilogram per second. The energy added to air by compressor, HC, is calculated by multiplying mass flow rate 0.00591 with specific heat capacity of air 1.005 and with the difference between temperature 1 and temperature 2. Then we calculated the power out of the motor and we got 804.3765246. And lastly, we calculated the heat emitted from compressor QC by using power out of the motor subtract the energy added to air by the compressor. For the data analysis, Table 3 shows the data calculated of HC and QC. The value of energy added to the air by compressor HC and heat emitted from the compressor QC is calculated by using formula given. 3 graph was plotted based on the value calculated and the data given, which is Figure 1 shows the graph of temperature versus time. Figure 2 illustrates the graph of energy added to the air by compressor versus time. And finally, Figure 3 shows the graph of heat emitted from the compressor versus time. For the discussion part, based on Figure 1, graph of temperature versus time, the outlet temperature of the compressor increases with time. This is due to the work is supplied to the compressor will compress the air. Over time, the heat is released from the compressor that will increase the value of temperature. Ideal gas law, which is PV equals to nRT, is used in this situation. This is because as the volume decreases due to being compressed by the compressor, the pressure increases, thus the temperature also increased. Based on Figure 2, graph of energy added to the air by compressor versus time, the value of energy added to the air by compressor HC increases as the time increases. This is made due to heat accumulative from the compressor in the system causes the temperature to increase. This causes the kinetic energy of a system increased, which lead to an increase in enthalpy. The amount of energy lost as heat and compared to the heat added to the air is equal to each other. By observing Table 3, calculated value for energy added to air by compressor and heat emitted from the compressor at time 31, 32 and 33, the value of energy lost and temperature is constant. Thus, an assumption can be made, which is as the time goes on this value will be remain constant, which is 804.377 watt throughout the experiment, even though when the energy loss as heat is increased over time.
Okay, so for the conclusion, to sum up, based on the experiment, the outlet temperature T2 gradually increases and remain constant after 31 minutes of heating. This shows that the single-stage compressor heats up the air very quickly. During the heating process, energy added to the air by the compressor Hc also increases exponentially, but the heat emitted from compressor QC decreases with time. This is because there may be some energy losses as the input energy is converted into heat and sound energy or used to pump the air. Steady state occur at T equals to 31 minutes because the heat emitted from the compressor and energy added by the compressor is 304.377 watt and 804.37 watt respectively. If the compressor outlet pressure P2 is reduced to 0.5 bar, the temperature will also decrease. Hence, the heat emitted from the compressor QC will be reduced as well. Okay, so that's all from us. Thank you.